Hello everyone, in this video I will show my project which is a GPU scheduler. First of all, I will explain what is my project, and then I will tell about the problem, and then I'll show that how my project solves that problem, and in the end I will show a quick demo about it in working. So the first question is, what exactly is my GPU scheduler? So my GPU scheduler is like mini single node Slurm. So essentially you don't have to place any scripts manually into GPU environments. This GPU schedulers handles that for you based on the best GPU selections via topology matrix and finding the best combination for you via backtracking. Now the second question is, what problems it solves. So first of all, let me show the problem. Okay, wait. Okay, so what is the problem? Suppose we have let's say Hugging Face script for fine tuning, and it requires 2 or more GPUs, and we have like 8 GPUs. So now what do you think, what will be the best combination for assigning the GPUs? Okay, or what will be the best combination for the GPUs for training? So if you would have trained it earlier, you would know that NVIDIA, actually in NVIDIA there is a command called nvidia-smi topo, and that is for topology matrix. So it gives scores based on GPU connections. Like if some GPU is connected via NVLink, then it will get the higher score. If some GPU is connected by PCIe, so NVLink to PCIe, so it will little bit less score, and if PCIe, so least score. So we get the topology matrix. And now the question is, how will you decide that this is the best combination? So it is very simple. Actually we can use combination. Like if there is 8 GPUs, we need the best 2, so we do 8C2 to find the best combination, and with topology matrix we can actually sum the whole values. So essentially we will get the hashed score, and then it will be done automatically, right? So we will get the best score, and then we can train it. So my GPU scheduler actually does the same thing. First of all, it accepts the job, like if you are using Hugging Face or PyTorch or DeepSpeed or anything for training or for inference, or even Unsloth, but Unsloth is best for single node. But anyway, you can choose any of these scripts, and then you give them what mode it is, like training or inference, and the number of GPUs you need, minimum RAM you need, and of course bandwidth high, it is for connections. And then this GPU scheduler will get the best score out of all the GPUs, and then it will launch the script. So I think I have explained it. Now I will explain about internals of GPU scheduler. Okay, so now we will go to the internals. First of all, we will create a connection. So my GPU scheduler will create a sock file, and it will bind and listen to every user connections, and once it receives a connection, it will start a thread which will essentially handle the request given by the user. So essentially the request will be JSON file, and once it accepts the JSON file, it will start on working. So there are 2 states, pending states and waiting state. So suppose there is a training, and then there is inference, and then there is again training. So first of all, whatever with the state is, so if the GPUs are free, then it will essentially start the training, and whatever be the next will be in pending state, and the next will be in waiting state. So it is actually very simple to understand, and I've already explained about the topology and the backtracking logic. Here you can see that. So essentially it is the same thing I've told earlier. You have with nvidia-smi topo-m flag, we can actually get the topology matrix, and then with backtracking we can actually get all kinds of combinations. Suppose I've already given example A with, suppose there are 8 GPUs and we need 3, so 8C3, and after that we'll add those weights and then we'll get the best combination for all the GPUs. And once it's done, okay, so it is like once it's done, it stops that whatever with the running, and then it will essentially assign whatever will be in the pending state. Okay, so now we will go to the internals. First of all, we will create a connection. So my GPU scheduler will create a sock file, and it will bind and listen to every user connections, and once it receives a connection, it will start a thread which will essentially handle the request given by the user. So essentially the request will be a JSON file, and once it accepts the JSON file, it will start on working. So what is this pending and waiting state? So suppose there is a job and it is submitted, and it is actually waiting for the scheduler to finish. So whatever be the job is submitted, it will automatically be submitted in the pending state. So once any job is completed, so the next waiting job, if that arrives and the GPUs are not free, then it will essentially go to the waiting state. So there are 2 states, and there is also a function named reschedule waiting. So it will, whenever any job finishes, it will see that if there is anything in the waiting queue or the waiting state, then that will complete first before the pending state. So pending state essentially accepts all the connections whatever you are sending, and once it's like first in first out, so that's why I have named it pending queue. And okay, so the next thing is the launcher. Okay, so what is set CUDA visible to it is for restricting the GPUs to see only the allocated ones, like the allocated ones can only communicate. And there is allocate master port. So this is for NCCL connections, which is multi GPU connections. And of course the for exec pattern, this is very common in everywhere. And then there is mark busy, which is for essentially for marking if the GPU is busy or not. And of course there is another thing for monitoring and rescheduling. So I have already told how if something goes to the waiting state, it will check. So this is the overview of the internal, how GPU scheduler works. So I think I have explained it enough. I think this diagram is explainable. It's very easy to understand this diagram. Okay, now it's time for quick demo. So I have actually, okay, this is actually the script which I am already running. So this is actually a mock file, which is there is a third-party library for running those NVIDIA things locally without worrying about the wastage of resources or in cloud. So I have also run that. So this script actually is running in a second terminal, and as you can see, so I have tested a lot before making this video. Okay, so there is a script I wrote makefile for testing it. Okay, suppose there is okay, so this is one. Okay, I've submitted a job, so now you can just see the state. So it is running one job and it requires 2 GPUs, so both are consumed. So now if I do it again, so essentially all the jobs, it essentially binds everyone and almost all the GPUs are combined. Okay, so that is it for my quick demo. I think I've explained almost everything. If I have missed something, please tell me. And if you want to look into the code, you can actually go to this URL, and the code is in the GitHub, so anyone can see it. Well, there is also diagrams you can see, and yeah, so I think I should mention that I took a lot of help from Claude and GPT for writing these scripts. And since I am essentially a student, I am not an expert in C++, so GPT actually finds lots of edge cases while writing code, which I miss most of the time. And this project is actually for me it is a little bit advanced. So it was a nice journey to learn along with AI, and I asked a lot of questions. So this is it. This was all about my project. I've also made I also want to make a multi-node GPU scheduler later on, once I'll get comfortable with the scripts. I will try to make the next part of this project, which will be multi-node GPU. So this is a single node. So thank you again, thank you for watching.